Hello, good day everyone. This is Japi08 and welcome to another episode or video of Differential Equation by Japi08. And today, our topic is elimination of arbitrary constants. I hope you guys are excited as me, as I really want to impart my knowledge, or I really want to help you guys to learn about what I know about elimination of arbitrary constant. What about differential equations? Alright, so let's get started. What is arbitrary constants, or where do we find arbitrary constants? So in these three examples, we call these examples as general solutions. Okay, so under differential equation, we have two types of equation. Generally, we have differential equation and general solutions. When we say differential equation, that's the main subject, that's the main topic. We find our equations having differentials, dy over dx is equal to y prime, having derivative. Okay, in differential equation, it can be as high as like to the third derivative plus to the second derivative to the first derivative plus to the y is equal to 0. It can be as high as like 39 derivative over with respect to the derivative of x raised to the 39. Okay, so differential equations are equations that has differential or derivatives in them. Okay, and differential equations are equations that represents, or ideally it represents a real world situation, a real world case. It represents changes. Okay, for example, dy over dx is equal to m, the slope of a line, right? So a differential equation when integrated, okay, let's move on. A differential equation when integrated, let's integrate dy over dx and dx, it will become y is equal to mx plus c. Okay, we learned that in integral calculus, when we integrate an equation, we add c on the right side to represent a value that we don't know or does not exist on a differential equation, but since we integrated, okay, it's a value that now can exist on the general solution. Okay, vice versa, when we differentiate any constant, okay, c is what we call arbitrary constants. When we differentiate any constant, for example 2, differentiate with respect to dx, it will become 0. So the c represents constants or values that when differentiated, it disappears into the differential equation. And when we integrate the differential equation to our equation, when we integrate an equation, we add c to represent the constant, and we call them arbitrary constant. Okay, we call them arbitrary because we don't know the value. It will change, or it can change to any specific case. Okay, it doesn't have any fixed, okay, meaning or value in the equation. When we integrate a differential equation, we now call this a general solution. Okay, general solutions are basically equations or solutions that describes or satisfies the differential equation. Okay, general solutions are equations that satisfies your differential equation. When your differential equation is integrated into integrated and your differential is done, right? If your differential equation is dy over dx integrated once, you will have your general solution with one arbitrary constant. Right? So vice versa, if your general solution is differentiated, if we differentiate your general solution, it will now eliminate your arbitrary constant. Okay, and why do we need to eliminate or differentiate your general solution? Because as general solution satisfies your differential equation, the differential equation also describes the behavior of your general solution. Okay, for example, it's the slope. It describes your line, dy over dx. Is this the slope describes how your straight line behaves in your Cartesian coordinate plane. And any differential equation will describe how your general solution will work. Okay? So in elimination of arbitrary constants, the idea is to eliminate the arbitrary constants and get your differential equation. Okay? So let's proceed to number 1. Finally, after explanation, we're gonna differentiate. We're gonna eliminate the arbitrary constants. Right? So number 1, x cubed minus 3x squared y is equal to c. So the idea is to eliminate c, the arbitrary constants. And because c is on the right side and doesn't have any variable x or y, dependent or independent variable beside itself, we can proceed to this differentiating. Differentiate x, we can do as follows: 3x squared dx, right? We put down or we drop down the 3 into a coefficient and minus 1 the degree. Minus, because 3x squared y has 2 variables in it, we're gonna be proceeding into product rule of differentiation, to which we differentiate the x first. It will become 6x dx y. We differentiate the x first. Then the second product rule, we differentiate y second, right? 3x squared dy. Make sure to put a parenthesis so that we don't get confused on the dxy. Is equal to the differentiation of c, which is, if c is a constant, then 0. Okay, any constant differentiated, it will become 0. Next, okay, let's simplify the equation. Right? So the goal is already there. We already eliminated the arbitrary constants. But for presentation purposes, we clean out our equation. Let's divide the equation by dx in order to get 3x squared minus 6xy minus 3x squared y prime. Y prime is equal to dy over dx, right? So by dividing the equation by dx, we cancel the dx on the first 2 terms, and we get dy over dx on the last term. So in our equation, we can notice, or we can point out that everyone has 3 or multiple of 3. We can also proceed to simplifying our equation, divide both sides by 3. Okay, and probably let's take out the common x value on this side, right? So 3 divided by 3 will become 1. X minus 2y, right? So 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. And taking out x on both sides, we get x multiplied to x minus 2y minus 3x squared y prime. Oh, the 3 should be gone because 3 divided by 3 is 1. Okay, this is now our differential equation, or the eliminated arbitrary constant. Okay, if we are going to put this on general form, okay, so I'm gonna explain about general form. General form of differential equation is usually in the form of the highest derivative first. For example, if we have a fourth derivative, okay, y 4 prime, then third derivative, then second derivative, first derivative, then y constant, then x variables. Okay, so a general form usually starts with the highest derivative going downward and all other values constant x on the right side. So if we're gonna represent this in general form, we can write down as like negative x squared y prime, okay, minus 2xy is equal to negative x squared, or divide both sides by negative 1, or multiply both sides by negative 1. It will become x squared y prime minus 2xy, positive 2xy, is equal to x squared. This is now our differential equation in general form for number 1. Okay, I hope I'm not too fast. Okay, so if I'm too fast, you can slow down or you can stop the video. Okay, stop the video. And I've been pointed out that my handwriting is very, very, very beautiful. I hope you guys like my handwriting. It's not as straight and clean as normally. Anyways, let's proceed to number 2. For number 2, we have, let's copy this. Y is equal to C1x squared C2 e to the x. Okay? So in eliminating arbitrary constant, the hint is how many arbitrary constants do you have. Depending on how many arbitrary constants you have, you differentiate your equation. Okay, you differentiate your equation into the order on how many constants you have. So if you have 2 constants, for example, this case, you differentiate it twice. If there's 3 constants, you differentiate it thrice. Okay, so we differentiate this equation twice. So this will become 2c1x plus 2c2 e to the 2x. Next is y double prime, 2c1 plus 4c2 e to the 2x. Okay, take note that even though we continue differentiating, okay, our c1 could be eliminated in another differentiation, although that's like extending the rule or not following the rule where we differentiate on how many constants. We only have 2 constants, so we're gonna differentiate until second order differentiation. But if we differentiate another one to the third order, the c1 will disappear. But our c2, it will not disappear, right? It will continue to be forever e to the 2x and just drop down 2 every time we differentiate it. It will just become 8, 16, c2 e to the 2x. Okay? So after differentiating, depending on how many constants we have, we can proceed to using elimination method or substitution method. Elimination method or substitution method. Substitution method. Or we can also use our matrix. Since we have 2 terms, we can proceed to using matrix, the basket method, and getting the determinant will result to getting your differential equation. So for now, let's proceed with elimination method or substitution method. Okay, fourth step in elimination method. The elimination method is an algebra process. We eliminate c1, or probably I'm gonna eliminate c2 first. So c2 is multiplied e to the 2x, and e to the 2x is a lot more complex term. Okay, so for example, we y double prime, we subtract y, the equation y, right? We subtract the equation y from y double prime when it's multiplied to 4. because y double prime have 2c1 plus 4c2 e to the 2x. But y prime, take note, y prime has like c1 x squared. Okay, so they don't have the same x squared. But c2 e to the 2x multiplied e to the 2x, when we multiplied y with 4 and minus it to the first equation, we can eliminate now c2, because 2 minus 4x squared multiplied to c1, that's our c1 coefficient, while c2 will have like 4 minus 4 c2 e to the 2x, and 4 minus 4 is 0, and any number multiplied to 0 will become 0. c2 will now be eliminated in our equation. Okay, so we can call this like our equation A. Okay, we now have to eliminate c1. Right, next, let's eliminate c2 again to the other equation. Now, in the process of elimination method, we eliminate c2 again, c2, right? So using the second equation, y prime, let's eliminate c2 by differentiate or subtracting y multiplied to 2 to the equation, 2c1x plus 2c2 e to the 2x minus c1, 2c1 x squared minus 2c2 e to the 2x. Positive 2 minus 2, it will become 0. Okay. Now we have y prime minus 2y is equal to c1 2x minus 2x squared. Okay. We have now our equation B. Okay, both have C1. We can now proceed to eliminating C1 by dividing, let's say, dividing A over B. Right? So this is a manipulation decision. We're just manipulating the equation into eliminating C1. Because C1 is both a multiplier, or both in multiply with its coefficient. So A over B will result with C1, 2 minus 4x squared, that's the C1A, while the B C1 is C1 multiplied to 2x minus 2x squared. Then the A left hand side is y prime minus 4y. The B left side is y prime minus 2y. We can now divide C1 with C1, which will become 1. Okay, and thus we eliminate C1. Okay, and simply by simplification, we can now get our differential equation. Okay, let's I'm gonna write this down more legibly. Okay, I'm gonna zoom in. This is now our differential equation, but we're gonna simplify it first for presentation purposes. Okay, notice that on the left hand side, there's no common multiple. Okay, on the right hand side, on the right side of the equation, there is a common multiple, 2, 1 minus 2x squared over 2x minus x squared. Okay, eliminate 2, and I'm gonna proceed on cross multiplying the numerator and denominator, so it will become y prime double prime minus 4y over, or multiplied to, x minus x squared. That's the denominator on the right side. Then y prime minus 2y multiplied to 1 minus 2x squared. Okay, at this point, after integration, it's a matter of algebra and manipulation into getting a simpler equation, or it's a matter of simplification. Okay, let's proceed with the y prime. Y prime, double prime, multiplied to x minus x squared. Okay, then negative 4y multiplied to x minus x squared, it will become negative 4xy, positive 4y x squared, because negative multiplied to negative is positive, 4y x squared, is equal to y prime multiplied to 1 minus 2x squared. Okay, then minus 2y plus 4y x squared. Okay, let me just write this down. Okay, so notice that there are common terms on the left and the right side of the equation, both positive, so we cancel them out. Right, and using the general form, we write down first y double prime x 1 minus x squared. Then we write down next y prime negative y prime 1 minus 2x squared. Then next is y, okay, plus y 2 minus 4x is equal to 0. This is now our general solution. This is now our, wrong. This is now our differential equation to our general solution and the equation with the eliminated arbitrary constant. We have now eliminated the arbitrary constant. Again, this is the differential equation to our general solution with the constant, and the differential equation does not contain any arbitrary constant. For our third problem, this is a lot more, okay, I can see this a lot more complex. Okay, third problem, it has e to the 2x and cosine 3x. There's two variables, okay, but the arbitrary constants, there's two arbitrary constants. Okay, proceeding as follows, we differentiate the equation with two arbitrary constants twice, because there's two arbitrary constants, we differentiate it twice. So this will become y prime and y double prime. Okay, in this case, it's a little more hard because e to the 2x and cosine 3x, it has two variables. Okay, and because it has two variables, let's proceed with C1 first. Let's differentiate e to the 2x first. 2 e to the 2x cosine 3x. Then differentiation of cosine will become negative 3 e to the 2x sine 3x. Next, C2. Okay, C2 will have 2 e to the 2x, product rule, e to the 2x first, sine 3x. Then, since sine is differentiated, it will become positive, positive 3 e to the 2x cosine 3x. Okay? Next, okay, we differentiate it again. Okay, we differentiate again. So we differentiate each term again. So 2 e to the 2x will become 4 e to the 2x. We differentiate cosine 3x, it will become now negative. Sorry. Okay, cosine 3x, product rule, remember. So we will have product rule. First, differentiate e to the 2x. Next, we differentiate cosine 3x. So once we differentiate cosine 3x, it will now become negative 6 sine. Let's write e to the 2x first. E to the 2x sine 3x. Because we differentiated cosine 3x, it become 3 sine 3x negative. Next, we differentiate the second term. it will become negative 6 e to the 2x sine 3x. Next, we differentiate sign. It will become positive 9 e to the 2x cosine 3x. Okay? Wait. With the, it's not positive, it will become negative. Okay? It will stay as negative. Because sine 3x differentiated to cosine 3x is positive. To positive cosine 3x. So the sign will not change. So that's C1. As for C2, we will have we will have 2 e to the 2x sine 3x. So 2 e to the 2x first. It will become 4 e to the 2x sine 3x minus or positive 6 e to the 2x cosine 3x. Positive because sine differentiated to cosine is still positive, but 6 times 2 from 3 sine 3x will become 6. Product rule. Let's explain this. Product rule. No, it differentiate e to the 2x first. 4 e to the 2x sine 3x. Then we differentiate sine 3x. It will become cosine 3x 3, which is multiplied to 2. It will become 6 e to the 2x. That's why it's 4 e to the 2x sine 3x. Okay, so the thing here in this problem is there's a lot of variable, but the key hint or the tip is we need to do it slowly or we need to do it carefully. Okay, and make sure we do our rules well. We are disciplined enough to follow the rules. Okay. First, differentiate 3 e to the 2x. It will become positive 6 e to the 2x cosine 3x. Then differentiate cosine 3x. It will become negative 9. Okay, negative 9 e to the 2x sine 3x. Okay. Okay, so now we could see that there's a lot of term, right? There's a lot of term. I'm seeing e to the 2x cosine 3x. I'm seeing e to the 2x sine 3x. Okay? Okay, I'm gonna simplify y double prime first. Y double prime first is equal to C1, C2, 4 e to the 2x cosine 3x positive or sorry negative 12 e to the 2x sine 3x minus 9 e to the 2x cosine 3x. Next is 4 e to the 2x cosine 3x. Oh, actually it's sine. For C2 it's sine 3x positive 6 or 12. It will become 12 positive 12 e to the 2x cosine 3x minus 9 e to the 2x sine 3x. Okay. Okay. I'm seeing a pattern here, right? So we can do as elimination method. We can use substitution method, but I'm seeing a pattern where sometimes in order to solve for complex equations, having the eye or having the experience to see the pattern is much better. So what do I see, right? So take note, this is e to the, I'm seeing the common terms. E to the 2x sine 3x. See e to the 2x sine 3x, that's C2. E to the 2x sine cosine 3x. That's C1. E to the 2x cosine 3x. Okay. E to the 2x cosine 3x. Wait, we can eliminate this further, right? 4 minus 9, that will become 5. I think that's right, right? 4. Wait, we can eliminate this further. Okay, now that we can eliminate or we can simplify this further, this will become negative 5 e to the 2x cosine 3x minus 12 e to the 2x sine 3x. C2, 4 or negative 5 again. Negative 5 e to the 2x cosine 3x plus 12 e to the 2x cosine 3x. Okay. For C2, it's not cosine 3x, it's sine 3x. Okay. Okay. So, in order to eliminate our C1 and C2, I could eliminate using y because they have the same term. E to the 2x cosine 3x. E to the 2x sine 3x. For C1, e to the 2x cosine 3. They have the same term. I'm gonna highlight this with this one. I'm gonna highlight this one with this one, right? Okay. We can eliminate that value. E to the 2x sine x. For y prime, okay, we have e to the 2x cosine 3x, negative 3 e to the 2x sine 3x. So, positive. So, take note that on the C1, we have e to the 2, negative 3 e to the 2x sine 3x. This one is negative 12. Right? So, here's the process. Okay? Here's the process. Okay? So, I'm just taking on the new terms. Right? I'm gonna eliminate the 12 first. Okay? I'm gonna try to eliminate the first. Okay? So, we have y double prime. We have y double prime, right? We have y double prime. Oh, wrong color. We have y double prime. Right? Now, y double prime has negative 12 e to the 2x sine 3x. This is 3. So, if we add 4y prime, or if we subtract 4y prime, okay, I will subtract 4y prime. Let's do that first, okay? Let's do that first. We subtract 4y prime. So, C1, we have for y double prime, negative 5 e to the 2x cosine 3x minus 12 e to the 2x sine 3x. For C2, I'm gonna write C2 on the right side. C2, negative 5 e to the 2x sine 3x plus 12 e to the 2x cosine 3x. Okay? So, for y prime, what is y prime? 2 e to the 2x cosine 3x, negative 3. Okay? So, for y prime, we multiply it by 4, negative. So, 2 e to the 2x cosine 3x minus 3 e to the 2x sine 3x. Okay? Plus C2. Oh. C2. Let's double check. 2 e to the 2x cosine 3x. 2 e to the 2x sine 3x. Okay? 2 e to the 2x, okay, sine 3x minus 3 e to the 2x cosine 3x. Okay, so take note, we can eliminate the second term, right? 2 e to the 2x sine 3x, 2 e to the 2x cosine 3x. Okay, we can eliminate the second term. If we multiply this by 4 and we subtract it to the other term, this one is positive. Oh, the right term is also positive. Okay, so okay, we can get y double prime minus 4y prime is equal to C1 Okay, negative 5. What is negative 4 multiplied by 2? Negative 8. E to the 2x cosine 3x. This will become negative 12, and minus, that will become positive 12. This will become positive 12. Positive 12, negative 12, that will become 0. Right? We can cancel that, and this will become 0 too as well. And for C2, we will have C2. We will have negative 5, negative 8. So that's negative 5, negative 8. E to the 2x sine 3x. Okay. Now that we have negative 5, negative 8, that's 13. Right? Negative 13. We simply multiply y to 13 and add it to our equation. Right? So y double prime minus 4y prime plus 13y is equal to negative 13 C1 e to the 2x cosine 3x minus 13 C2 e to the 2x sine 3x. Okay, that's y double prime minus 4y prime and plus 13y plus 13 C1 e to the 2x cosine 3x plus 13 C2 e to the 2x sine 3x. We can now cancel the equation because negative 13 plus 13 is 0. Our differential equation now is y double prime minus 4y plus 13y is equal to 0. Okay, this is now our answer. This is now our eliminated arbitrary constant equation or differential equation in general form. Y double prime minus 4y plus 13y is, oh, forget the y prime. This should be y prime. Okay. Y double prime minus 4y prime plus 13y is equal to 0. Okay. So I hope you guys learned on how to eliminate arbitrary constants, especially these 3 problems. At the end of the day, okay, at the end of the day, we don't know if this will be the equations that will be handling in your exams, in your challenges, in your math exercises, but it is important that you know the process. Once we got our equation or our general solution, we eliminate the arbitrary constant by differentiating on how many arbitrary constant you have. If you have 2 arbitrary constant, you differentiate it twice. If there's 3 arbitrary constant, you differentiate thrice. Okay, and you can use elimination method or substitution method. Okay, so in this case, we use elimination method, but we got lucky because there's like a common term between the first on each equation, right? E to the 2 is cosine 3x has been what you call that? Showing, or we can notice the e to the 2x cosine 3x on each differentiation, then e to the 2x sine 3x on the second differentiation, right? So there's like common terms on each differential equation. So we it's much more easier to eliminate common terms. Anyways, that will be our episode. That will be our examples for today. I hope you guys learned, and if you guys have learned or if you like the video, please like the video and subscribe, and catch you guys for more. Right, see you guys later. Bye bye.